Okay, today's lesson deals with radicals. I call them radicals. They're square roots, which we've done a little bit before with. We know some of the perfect squares, 1, 4, 9, 16, 25, 36, and so on. I'd like for you to know them to 25 or 625. Also with exponents, it's even exponents are perfect. So we're showing off perfection, ladies and gentlemen. Here's the symbol that you're going to use for square root. I call it radical. That's just me. What this says here is we have two numbers that are multiplied together, a and b. We can break them up into two separate radicals, which is helpful. Makes no sense with letters to me either. But I look at this and I say, okay, 80, is that perfect? No, it is not, but it does have perfections. We all have perfections inside us. We're going to show ours off. In this case, what's the largest perfection that will divide into 80? So I think, use my head, and 16 times 5 is another way of writing the 80. Now, according to this above, we can break it up into square root 16 times square root 5. Again, show off your perfections. Show them off. So, perfect? Yes or no? Yes, it's perfect. Show it off. So bring it outside. Square root 16 is perfect. Show it off. That perfect? No, you stay. You stay inside. And that's another way of writing square root of 80 or radical 80. This is read as 4 square root 5 or 4 radical 5. This also works with division. If you have two numbers inside of one radical dividing, we can break them up into two separate radicals. For example, 4 and 81. I can break this up into the square root of 4 over the square root of 81. Perfect? Yes. Let's show you off, baby. Perfect? Yes. Let's show you off. There it is. So let's look at some examples down here. Square root 27. Is it perfect? No, it is not, but I see perfection. I look for the good. You should look for the good in everyone. Look for perfections. The largest perfect square that will divide in, let's see, 1, we don't really talk about. 4 won't go in there. 9, there it is. Woo! Perfect. Show it off, baby. Perfect. You stay. Radical 98. Perfection. Let's see. 16, no. 25, no. 36, no. 49, yes. 49 times 2. Perfect? Yeah. Show it off. Perfect? No, you stay. So this is read 7 radical 2. Another way of simplifying radical 98. Let's break it up. Perfect? Nope, you stay. Perfect? Yep, there it is. Very simple. Now, in the past we've talked about no zero buts. No zeros on the bottom. We've talked about, yeah, that's about it. So we're also going to say no radical buts. Have you ever seen a radical butt? That's weird. I know it. So if I look here, radical 5, I break up radical 2. Neither one of those can be broken up into perfections, and they aren't perfect. So what the heck do? We cannot have a radical butt. That's disgusting. Ugh. Well, you've heard that you can adjust fractions. You've done them in the past. 1/2 you could rewrite as 2/4 by multiplying top and bottom by the same number. We can do the same thing here. Anybody know what radical 2 times radical 2? Let's ask everybody. Radical 2 times radical 2. That gives me radical 4, which is perfect. If you multiply two radicals and it's the same inside the radical, you get that value. What you do to the bottom, you have to do to the top. Well, what's radical 2 times radical 5? Guess what? It's radical 10. They're both inside. Can you reduce those? No. One's hiding inside because it's not perfect. The other one's perfect. We cannot combine those at all. That one takes a little practice. Just recognizing that you have a radical but. It's pretty easy to see. It's weird. Now come over here. This is called a complex number. It has a number added to a radical. Oh my gosh, what the heck are we going to do? Well, let's take a look through memory lane. What are we going to do? If I multiply by radical 2, which is the normal response here, when I distribute that, I'll still have 7 radical 2 plus 2. I still have a radical but. So our almost twins is going to come into effect here. Simplest thing to do is take that exact same complex number and write it down. Make it the almost twin. So if this is plus, this would be minus. And what you do to the bottom, you do to the top. Now, let's do the top because it's easier. 3 times 7, 21. 3 times radical 2. Now, it's not radical 6 because one's outside, one's inside. So we rewrite it as 3 radical 2. That's just like a letter. Now, here, almost twins. Do you remember what happens with almost twins? Let's take an almost twin example over here. X minus 2 times x plus 2. Oops, I got to get over there. There we go. Sorry about that. You get x squared minus 4, and then your two smiles, remember, negative 2x, positive 2x. They eliminate, so you're just left with this. The middle term drops out. So what's the shortcut then with almost twins? Multiply the first two, multiply the last two, and you're done. Well, let's do that here. We have almost twins. 7 times 7, 49. Radical 2 times radical 2. Please say not radical 4, but yes! Good job. 2. That can simplify to 7. 47. And we leave it just like that. Done. This one is the most difficult when you've got a complex number. Look for the almost twin. Now, how does that apply? Let's take a look. Solve this equation. Let's just solve it like this is a variable, like you did in 8th grade. Minus 5 minus 5. Divide by 3. You've done this before. And now we're left with x squared equals 12. So we're looking for a number times itself. Here's the easiest way. Do you know what the square root of x squared is? Yes, it is. X. So I take the x, and if I square it one side, what must I do to the other? I square root here, so I must square root there. What's the square root of 12? Look for perfections. Sorry about my fat fingers. Look for perfections. Yes, 4 and 3. Perfect? Yes, it is. Show it off. Come here, baby. Perfect? Nope, you stay. Now, back a second. How many solutions do we have here? So what are our solutions? Well, let's take a walk in memory lane again. X squared equals 16. We had it on the board today. X was positive and negative 4. Don't forget the positive, negative. You're talking about two answers here. Positive 2 radical 3 and negative 2 radical 3. Let's come over here to this tougher one. Oh boy. Well, let's add 7. Let's isolate the exponent. That's what we're going to do. Isolate it. Get it all by itself. And how do I get rid of a fraction? Just multiply by 5. Now, that doesn't distribute. It just cancels out. And what you do to one side? So now I have 7 plus 3 quantity squared equals 35. What did I do over here when I had a squared? That's right. Square root both sides. So now I'm left with what's inside the radical. Take square root of something squared, you're just left with that z plus 3. Square root of 35. Here's where everybody makes a mistake. Everybody will put 35, but what do we miss? Plus or minus, because how many solutions? Last step, throw the 3 over. And we'll just leave it written like that. Complex number. That is about what we'll cover with radicals. Now we'll get into something else on the next one.